True Projects. In this video, we are going to explain the project MalFSM Feature Subset Selection Method for Malware Family Classification. Introduction. As our reliance on digital technologies grows, so does the threat of malware. Malicious software designed to disrupt or gain unauthorized access is becoming more prevalent and sophisticated. In this landscape, MalFSM emerges as a critical tool offering a straightforward yet powerful solution for efficiently categorizing different types of malware. Its role becomes increasingly vital in countering the escalating challenges posed by malicious actors. Gone are the days when malware only targeted traditional computers. The digital age witnesses malware affecting a broader spectrum, including smartphones and Internet of Things devices. MalFSM recognizes this evolving landscape, emphasizing the need for improved detection methods that extend beyond conventional computing platforms. By acknowledging the ubiquity of malware threats, MalFSM positions itself as a versatile solution adaptable to the diverse digital devices that populate our interconnected world. Anti malware researchers grapple with the complexities of an ever evolving threat landscape. MalFSM steps into this scenario as a user friendly framework, acknowledging the challenges faced by researchers and offering a simplified approach to malware family classification. By providing a more accessible toolkit, MalFSM aims to empower researchers in their ongoing efforts to stay ahead of the dynamic nature of malware. Understanding and combating malware begins with the extraction of meaningful data from malicious code. MalFSM addresses this crucial aspect by extracting opcode sequences, key data indicative of malware behavior. The extracted information is then organized into a streamlined feature matrix. This approach simplifies the process of automatically categorizing malware, optimizing the use of time and resources for researchers and analysts. And in the realm of cybersecurity, striking a balance between efficiency and accuracy is paramount. MalFSM stands out by achieving this delicate equilibrium. Through real dataset testing, MalFSM demonstrates its ability to bring efficiency without compromising accuracy. Its practical value becomes evident as it proves to be a valuable asset for analysts, contributing to a deeper understanding of malicious code and its various classifications. Object of the project. So, as I mentioned earlier, the central goal is crafting a machine learning model adept at predicting Microsoft malware effectively and reliably, contributing to enhanced cybersecurity measures. The emphasis is on training machine learning models with Microsoft malware data to achieve high precision in predicting malware presence. This ensures accurate and reliable predictions in real world cybersecurity scenarios. And we aim to implement a diverse array of machine learning models including XGBoost, Random Forest, Decision Tree, Deep Forest, VGG, and Transformer to compare their performance seeking the most effective model for precise malware prediction. And to enhance model efficiency by employing advanced feature selection methods. This involves strategically choosing pertinent features from the Microsoft malware dataset, optimizing the selected models for efficiency, accuracy, and real world applicability. Requirements needed to execute this project are software requirements. Software needed is Anaconda, primary language used is Python, front-end framework used is Flask, backend framework used is Jupyter Notebook, database used is SQLite 3, and front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of law of work. So the first step is important required packages. So in this step, essential libraries such as NumPy, Pandas, sklearn, Matplotlib, and Seaborn are imported to facilitate data manipulation, analysis, visualization, and machine learning model development. The second step is exploring the dataset. Here, a comprehensive exploration of the Microsoft malware dataset is conducted to understand its structure, features, and potential insights. This step is crucial for informed data processing and model building. The third step is data processing. In this step, duplicate data is removed to ensure data integrity and irrelevant columns are dropped for streamlined analysis. This enhances the dataset's quality for subsequent steps. The next step is visualization using Seaborn and Matplotlib. So here, Seaborn and Matplotlib are employed to visualize patterns, relationships, and distributions within the dataset. Visualization aids in identifying trends and outliers, providing insights for subsequent analysis. The next step is label encoding using label encoder. In this step, categorical data is converted to numerical format using label encoder, making it compatible with machine learning models that require numerical input. The next step is feature selection. In this step, features are selected based on their relevance and significance for model training. Methods such as ANOVA, select k-based with chi-square, mutual information, recursive feature elimination that is RFE with random forest, and RFE with logistic regression are applied. The next step is train and test split. Here, the dataset is split into training and testing sets. Features that is X and the target variable that is Y are identified, setting the stage for model training and evaluation. The next step is training and building the model. In this step, various machine learning models including XGBoost, random forest, decision tree, deep forest, VGG, and transformer neural network are trained on the dataset. This step involves teaching the models to recognize patterns and relationships within the data. And in the next step, hybrid models such as the voting classifier and stacking classifier are introduced to combine predictions from multiple individual models, aiming to improve the overall accuracy and robustness of the final prediction. And as an extension again, Flask, a web framework, is utilized for creating a user-friendly frontend. SQLite is integrated for user authentication, allowing secure sign-up and sign-in functionalities. So after signing in, users provide input data, which undergoes pre-processing to align with the trained model's requirements. The pre-processed user input is fed into the trained models for predicting malware presence. Each model contributes to the final outcome. And the predicted outcome is displayed through the front-end interface, providing users with insights into potential malware threats based on their input data. This interactive system enhances user experience and real-world applicability. Now we'll understand about the algorithms used. So the first algorithm built is XGBoost. So XGBoost, that is extreme gradient boosting, employs a sequential boosting approach combining weak learners into a robust model. It corrects errors iteratively, making it efficient for malware prediction, handling intricate patterns and providing accurate results. The second algorithm built is random forest. So random forest builds multiple decision trees, enhancing accuracy and managing overfitting. This algorithm is robust and particularly useful for classifying malware instances due to its ensemble learning approach. The next algorithm built is decision tree. So decision trees are interpretable models that make decisions based on features. In this project, they serve as a foundational algorithm for understanding the structure of the Microsoft malware dataset. The next one is deep forest. So deep forest cascade structure of random forest allows it to capture hierarchical features. This is beneficial for complex datasets, making it suitable for detecting patterns in malware instances. The next one is VGG, that is Visual Geometry Group. So VGG, a convolutional neural network, excels in feature extraction from complex data. Its deep architecture aids in learning intricate patterns in malware datasets, contributing to accurate predictions. The next algorithm built is Transformer NN, that is Transformer Neural Network. So Transformer NN use self-attention mechanisms for sequential data. In this project, they prove effective for capturing dependencies in features crucial for understanding the sequential nature of malware data. Now we'll understand about the feature selection techniques used. So, ANOVA assesses feature variants, identifying those crucial for malware prediction. Select K-based with chi-square focuses on key features, optimizing accuracy. Mutual information measures feature dependence, enhancing efficiency. RFA with random forest systematically improves relevance, while RFA with logistic regression optimizes feature selection for precise malware prediction. Together, these techniques fine tune the model, maximizing accuracy in identifying potential threats. Now we'll see the comparison graphs of the algorithms built using select k-based with chi-square feature selection technique. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So, accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. So F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. So these are the comparison graphs of the algorithms built using features selected using ANOVA technique. These are the comparison graphs of the algorithms built using features selected using mutual information technique. These are the comparison graphs of the algorithms built using RFE with random forest feature selection technique. And these are the comparison graphs of the algorithms built using RFE with logistic regression feature selection technique. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is archive folder in which I have Microsoft Malware dataset with 9 different class labels on which we will train the models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML pages. This is model file which contains algorithm information which will be loaded into the project during runtime to utilize the trained models. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. So use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So now click on this. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password and click on login button. So it has redirected us to the classification page. Now we have to fill in these parameters and click on predict button to get the classifications. So first we'll understand these parameters. So the first one is ASM commands add. It adds the source operand to the destination operand and stores the result in the destination operand. This is ASM commands call. It calls a procedure or subroutine at the specified address. This is ASM command CMP. It compares the source operand with the destination operand but does not store the result, only the flags are affected. This is ASM commands DAA. So DAA is decimal adjust accumulator. It adjusts the contents of the AL register after an unpacked binary coded decimal, that is BCD addition. This is ASM commands DW. It declares a word variable in assembly language. This is ASM commands NP. So it marks the end of a procedure in assembly language. This is ASM commands IMUL. It performs signed integer multiplication. This is ASM commands in. It reads a byte or word from an input port. This is ASM commands INC. It increments the value of the specified operand. This is ASM commands JL. So JL represents jump if less. It transfers control to a different part of the program if the less than condition is met. This is ASM commands JMP. It unconditionally transfers control to another part of the program. This is ASM commands JZ. So JZ represents jump if 0. Transfers control to a different part of the program if the 0 flag is set. This is ASM commands MOV. So it moves the contents of the source operand to the destination operand. This is ASM commands OR. It performs a bitwise OR operation between the source and destination operands. This is ASM commands POP. So it removes the top value from the stack and stores it in the specified operand. This is ASM commands ret. It returns control from a procedure to the calling program. And this is ASM commands test. It performs a bitwise add operation between the source and destination operands, affecting the flags without storing the results. So now we'll fill in these parameters. So ASM commands add would be 1158. ASM commands call would be 3769. ASM commands CMP would be 2366. ASM commands DAA would be 47. ASM commands DW is 5079. ASM commands NP would be 1443. ASM commands IMUL would be 66. ASM commands in would be 2015. ASM commands INC would be 327. ASM commands JL would be 142. ASM commands JMP would be 1474. ASM commands JZ would be 1802. ASM commands MOV is 12592. ASM commands OR is 10346. ASM commands POP would be 2448. ASM commands ret would be 1873. And ASM commands test is 1406. Now click on predict button. So here we can see the outcome, that is malware type is ramnet. So now click on this, click on home link. We'll try again giving another set of parameters. So I have entered the parameters. Now click on predict button. So we can see the result, that is malware type is lollipop. We'll try again. Click on this, click on home link. We'll try giving another set of parameters. So I have entered the parameters. Click on predict button. So this time the outcome is malware type is Kellyho's version 3. We'll try again. Click on home link. So this time ASM commands add would be 629. ASM commands call would be 82. ASM commands CMP would be 23. ASM commands DAA would be 125. ASM commands DW is 216. ASM commands NP would be 11. ASM commands IMUL would be 0. ASM commands in would be 78. ASM commands INC is 71. ASM commands JL would be 0. ASM commands JMP would be 61. ASM commands JZ is 19. ASM commands MOV would be 402. ASM commands OR would be 326. ASM commands POP would be 153. ASM commands RET would be 16. And ASM commands test would be 15. Now click on predict button. So here we can see the result, that is malware type is window. So similarly, according to the given parameters, we can get other type of malware as result. So now click on this, click on sign out. So the conclusion here is the project successfully developed and implemented effective machine learning models including XGBoost, random forest, decision tree, deep forest, VGG and transformer neural network for accurate malware prediction. Advanced feature selection techniques such as ANOVA, select k-best with chi-square, mutual information, RFA with random forest, and RFA with logistic regression were employed to optimize the models, ensuring the inclusion of relevant features. Extension efforts introduced hybrid models like the voting classifier and stacking classifier, combining predictions from individual models. This significantly improved prediction accuracy and robustness. And the implementation of a Flask framework with SQLite integration provided a user-friendly frontend, allowing for secure sign-up and sign-in and seamless user input processing for malware predictions. So the project's comprehensive approach from model development to feature selection and front-end integration ensures real-world applicability in cybersecurity. It contributes to the ongoing efforts in enhancing malware detection and cybersecurity practices.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.